Okay, last section, last conic section part. And we're going to finish up hyperbolas today. Where are the rectangles at? And all your work. We're going to write an equation for a hyperbola today. So first of all, let's just write down our hyperbola equations. There are two of them. X squared over a squared. What's in the middle for hyperbolas? Minus y squared over b squared equals 1. Okay, remember, those are hyperbolas that open left and right together. Okay? Then we have the other kind. And the other kind start with y squared. Y squared over b squared minus x squared over a squared equals 1. And those are hyperbolas that will open up and down. Now, one thing I didn't tell you yesterday that I'll go ahead and tell you today is that this right here, in between the vertices, yeah, bless you, in between the vertices, that's called something. From there to there, and there to there, okay? It's called, and it's got a fancy name, it's called the transverse axis. Transverse axis. Basically what that is it's just the length or the distance between the vertices, okay? It's from one vertex to the other vertex. It's called the transverse axis. So it goes side to side when your hyperbola opens side to side, and it goes up and down, it's vertical, okay? So it's called a transverse axis. All right, the other things that you know already is you know that c squared equals a squared plus b squared. Okay, you know that. And then you also know that y equals plus or minus b over ax for your asymptotes. Okay, that's just kind of like a reminder of all this stuff because we're going to need this to know all this when we make our equations here. So I've got like, I don't know, 3, maybe 4 examples. We'll see how it goes. All right, number 1. Here we go. Suppose that they want you to find an equation of a hyperbola, and we're given a couple of things. I will always give you enough, all right? You might not think it's enough information, but it is. So find an equation of a hyperbola given that the foci are at 0 plus or minus 5, and the vertices are at 0 plus or minus 2. Now, even if, yeah.
Is a hyperbola, is that plural for both sides?
That's one graph. So that is a hyperbola. Both of those things together make up one graph. Yeah. Okay. Now, even if I didn't tell you this was a hyperbola, you can tell it is if you go to graph it. Okay? Let's graph this thing real quick. My suggestion to you is to sketch a little graph of the information they give to you so you can see what's going on, because a picture is worth 1,000 words, right? So you go to foci, 1, 2, 3, 4, 5, and that's 1 point. 1, 2, 3, 4, 5. Go to the other foci, and it's right there, okay? And then your vertices are at plus or minus 2. So here's my one vertex, and here's the other one. And so I can tell right away that this hyperbola is one of the hyperbolas that's opening up and down, okay? Because, a couple reasons. One, those foci, they have to be inside of that bowl. They're inside of an ellipse. They're inside of a parabola. They're inside of a hyperbola. And so now we can write our equation, okay? So what am I going to start with? This is an up and down hyperbola. So I'm going to start with y squared. And then minus x squared equals 1. Okay. It's a lot like the ellipse, right? Or, yeah, ellipse. But we have to decide which one's first, and there's always a minus in between hyperbolas. So now we need to figure out what a squared and b squared are. Well, one of them I have. I have this right here. From the center to my vertex is what? How far is that? 2. So this is going to be 4. Perfect. squared. You're catching on. Good. Okay, now, no, it's okay. Better late than never. All right, the foci right here, anytime you're given the foci in a problem, you have to use the foci equation. Foci equation, c squared equals a squared plus b squared. Okay, remember, if this is minus, then your foci will be plus, and then the other way too, okay? All right, so C is the distance from the center to your foci. Here's my center at the origin to my foci. How far is that? It's 5. So c squared is 25. A squared is the number underneath x squared. That's my question mark. That's what I'm trying to find. And b squared is what? 4. So subtract 4 to the other side. A squared equals 21. I can go over to my equation and put 21 in, and that's it. Done. Okay? Takes a little while, but I think these are manageable, especially if you could do them when you did ellipses. They're a lot like ellipses. All right, number 2. You want to try one now? No, not really? Okay, I'll do this next one with you. I get paid either way, so it's cool. All right, foci.
I don't get paid either way.
No, you don't. You have to actually pay to go here, or your parents do. And thank them because it's a lot. All right, so here we go. Vertices. Plus or minus 1, 0. Okay. What's he singing? Is he being funny today? Oh, okay. Are you singing that in Madrigals or something? No?
We sing in chapel every week.
Oh, okay. All right, here we go. Foci and vertices. Okay, so my suggestion to you is to draw a picture of this. Don't start with going right to your equation because we don't know if it's x squared first or y squared first, okay? So we're going to go to foci, which are at 1, 2, 3, 4 in each direction on the x-axis. So those are our foci. And then our vertices are just 1 in each direction. Okay? And so this graph is going to open left and right. That's our hyperbola. Okay, it could be wider or skinnier, it doesn't matter. That's like a sketch of it, a little rough draft, if you will. All right, so now let's go ahead and write our equation. Because it's opening side to side, we know it's going to be x squared over something minus y squared over something equals 1. Now let's find out what these somethings are. One of them we have. I know the distance out to my vertices on x is 1, right? Distance of 1. 1 squared is simply 1. And you don't have to write that there. You could have just had x squared. That's fine. But I like to, that's fine. You can have 1 on the bottom. Okay, now foci. I haven't used this information yet, but we need to. We're going to do c squared equals a squared plus b squared because we're trying to fill in that blank right there. We need b squared. All right, so let's talk about this. What is c squared? Well, from the center to my foci, how far out is that? If you count it, it's a distance of 4. From the center out to the foci. Not vertex to foci, but the center out to the foci. It's a distance of 4. So 4 squared is 16. A squared is 1. Go ahead and solve. Subtract 1. B squared is 15. And you just plug it in, and you got it. Yes? Did I lose you? All right, you get to try one now. Here we go. And don't say no, because you have to try this one.
Okay.
All right. All right, let's say that our vertices are at plus or minus 3, 0. And our foci are at plus or minus 6, 0. Okay, it's a lot like the last question. You need to find an equation for the hyperbola. All right, you try it. So let's do it. I would graph this 3 and -3. Foci are out here at 6 and -6, way out here. So this hyperbola It's going to open left and right. Now, you gotta graph that. You really do. You gotta picture it, visualize it. That way you can say x squared minus y squared equals 1. Okay. Now you have one of them. They're really nice. They usually give you that one. The next problem we're going to do is kind of a little trickier, but this is a distance of 3. So I'm going to go over here and put 3 squared is 9. All right? Foci. Foci are a distance of 6 out left and right. And so when I do my foci equation, I'm going to do 36 equals a squared plus b squared. So what did you get for b squared? Subtract 9. What do you get? 27. Very good. So b squared equals 27. And then go up here to your equation, plug in 27. Who got that right? Yes! Like 5 of them. The other, yeah, a bunch of people aren't listening today. All right, here we go, number 4. Last one. Okay. They tell us here that the transverse axis, okay, you got to know what that is in order to do this problem. So I told you what it was a minute ago. The transverse axis is vertical and is 4 units. Okay, we'll talk about what that means in just a minute. And then it says that the central rectangle, remember those rectangles that you drew to graph these things yesterday? Okay, then you did the problems wrong. All right, the central rectangle is a 4 by 6. And we have to come up with the equation. That was like a smarty, like, All right, so here we go. Now, we're centered at the origin still. We haven't moved. So the transverse axis is vertical. That means it's up and down. So we know that, okay? It's vertical and it's 4 units long. Now, if it's 4 units, then how far is it to each vertex? 2, right? 2 up, 2 down. That makes a total of 4. Okay, so the transverse axis is vertical. That means our hyperbola looks like that. Okay, which means it's going to be y squared minus x squared this time. Y squared first minus x squared. All right, then the central rectangle. Remember when we did these rectangles? Okay, the rectangle is a 4 by 6. So that means that if I were to draw this rectangle, this side would be 4. They gave me that. And this side over here is 6. Now, if the rectangle is 6, how far do you go left and right to get a length of 6? Perfect. 3. Okay? It's like you're taking half of everything. And then when you put these in over here, you have to square them. So this one to here is 2. 2 squared up and down would be 4. This one over here is 3 because it's 6 total. And so when you square it, you get 9. And that's your equation. Nice. Oh, so the rectangle they say is a 4 by 6. So if this side is 4 and this side is 6, that means it would be a 3 and a 3 in each direction to make the total of 6.